Hello and welcome back. I hope you have enjoyed that short break to have a bit of a refresher, had a drink, and stretch your arms and legs, and you're back to learn more. So, what's in this session? I'm going to give you a comparison of another microcontroller to STM32. This is from Texas Instrument TIVA. You need to download this TIVA reference manual, and uh, I'm comparing with TM4C123GH 6 PM. I'm going to go into the data sheet. So just one moment, I downloaded earlier. So this is the TM4C12 3GH6PM microcontroller datasheet. You need to go to the functional block diagram so I can show you the difference of the two microcontrollers. Just give me a moment. Block diagram. Let's see, overview. Let's go in there. I'll close this. And this is the overview. I'm trying to get you the functional block diagram so you can see. Yeah, there it is. Sorry, it is on page 48 on that manual, page 48. I'll maximize. Okay, I hope you can read it now. So it is from Texas Instruments, TM4C123GH 6PM. So every microcontroller runs on its own bus operating frequency. So the microcontroller, when you say ARM Cortex M4, its operating frequency is 100 megahertz. That's nothing but the system bus. That's what the maximum speed it can run. So likewise, Texas Instrument, this one can run only for 80 megahertz, up to 80 megahertz, but the concept and the principle it's still the same. They use the ARM Cortex M4, but the process speed is different. That's 100 megahertz that we are learning to 80 megahertz. So if you see the structure, this also connects to the bus matrix via the system bus. The flash memory, as we learned from the STM32, if you want to access to the flash memory, you can do so by the D bus and the I code bus. D bus is the data bus, I code bus is the instruction bus. Whereas if you want to connect to SRAM, you can use only the system bus, the S bus. So this one doesn't have a bridge like for us in the STM32. There is the bus matrix is connected to a bridge, and the bridge is where it separates from high speed frequency to the low speed, whereas the Texas Instruments, this particular microcontroller doesn't have the bridge. It directly connects to an advanced high performance bus, AHB, and an advanced peripheral bus. The advanced high performance bus is connected if you want to communicate or interface with DMA, EEPROM, all the GPIOs, then you need to use advanced high performance bus. Whereas if you want to use serial peripherals for UART, I2C CAN, then you need to use the peripheral bus. So this is the difference between the other microcontroller STM32 that we are learning to TM4C123. Both works on the same M4 architecture but different speed. I just want to show you its architecture compared with our learning of STM32 F411. Now let's get into clocks. There are three different clock sources, as you may be all known by now. Again, the system clock can be divided into three different clocks. What are they? HSI, HSE, PLL. HSE is high speed internal oscillator clock. HSE is high speed external oscillator clock, which is in some microcontrollers there will be internal clock. Actual pin will have an internal clock, whereas the high speed external clock, some pins will have a special functionality, so you can use the external clock to write to that pin. And PLL is the one where it takes the low frequency clock and converts to high frequency clock, so that's where the PLL is used. Also, these devices will have the following secondary clock sources. When you take an internal kilohertz clock, the LSI low speed internal RC, which drives the independent watchdogs, for example, for any real time clock applications, then you use a kilohertz clock. Whereas in some microcontrollers, if you see, you have an optional RTC, the real time clock for the real time ticker. So you use a 32.768 kilohertz clock. So that these are all the different clocks that's readily available. I'm sure I have the schematics to show to you. Just one sec. Schematics data sheet. Is that the schematics? No. Just one sec. I'm checking to see where schematics. No, that's not it. Schematics, come on. I'm just downloading the schematics so I can show to you. Just one sec. Okay, so this is the nuclear board that we are using on page 2. If we go here, this is page 2. You said, so that's a TMS T clock. So I'm trying to point out the frequency. So this is the RTC clock, 32.78 kilohertz clock. So this is connected to PC 14 and 15. This is for the real-time clock that's coming up to connect. Whereas the system clock, it comes from the MCO. I think it's on page 5 as we scroll down. Micro, that's the extension. MCV battery, ST clock, SP11. Okay, the clock that we're going to use, it's 8 megahertz, which it's not applicable, so we are not using that. The STM nuclear board has its own circuitry that you get the clock from MCO, which is another circuitry, and that's where the main clock from that you get from the other circuitry. So this is about the schematics. Let's go into here. So what about the clock sources? There is 3 different clock sources that you can refer to. There is a crystal oscillator, which can be external to the MCU. MCU is nothing but microcontroller unit. The crystal oscillator is the one you can have as a separate boost frequency oscillator for RC oscillators, and you can connect that to the microcontroller via functionality pin, a specific pin. The RC oscillator is internal to the MCU. Some MCU has internal built-in oscillator, so you don't have to have external clock. It will work in the internal clock. The PLL also internal to the MCU clock source, but this takes the low frequency and converts to high frequency. So that's the PLL best clock loop. So what we learned today so far, we learned about different memory maps, which every peripheral will have a starting address and the ending address, and you have learned about how you can fetch any information from the flash memory and how you can fetch any information from SRAM. Sometimes with the help of linker scripts, you can also save or store data information in the SRAM that you will learn sometimes through the series. I'll show you how. Otherwise, you can also download the header files which already has the peripheral memory mapped, and you can just interface it. Otherwise, you can also learn to write from scratch. So these are all the different types there. And then you learned about the MCU bus interface. There is three different buses: the data bus, instruction bus, and the system bus, and how those buses are connected to either advanced HB1 or APB1 or APB2. And then you learned about three different clocks: the internal clock, the external clock, and the phase lock clock. So as I point out early, you have to develop your mindset while you're developing your skill set as well. So I got this for you for today. When you start with a positive mindset, thinking positively, whatever you want to do, if you start to think positively, all positive things will start to happen. So your subconscious mind links to that thinking, and only that process comes. Whereas when you have negative mindset, all negative things will start to happen. So your subconscious is controlling to negative things. So oh yeah, you can put it off until tomorrow, sort of thing. So whenever you come up with any negative things, just throw that away. Don't get into that. Just always focus on positivity. So because always thinking positive, that will lead you to do good things, and that will make you as a better person, and that will contribute to a better world. So everyone, including me, I have to start, and you have to start to change this world. So you need to always think positive, and you can do good things when you are in a positive frame of mind. And that happened through me, with me, and also all my mentors will agree. Positivity, you can do wonders when you are in a positive frame of mind. Also, please don't forget about the involvement. If you follow this through, post your achievements into our Facebook, so everyone can learn and motivate from each other, and we help each other. Write down your top 10 goals, that gives you a point, and top 10 ideas to achieve those goals. And please try to get 30 minutes, at least 30 minutes, but please push yourselves to do more than that. By now you should all do at least 10,000 steps, as from some of the research, from medical research, people say the more you walk, it's better for your own health. You lose body fat, and also it helps all the vital organs to function really well. So that's the basic necessity to do workouts, especially walking helps a lot. And also dedicate 15 minutes to meditate or pray, and 10 minutes to visualize actually you achieved all your goals. So spend at least 10 minutes for that, and 10 minutes to plan your daily activities. So what are you going to do for the rest of the day, or what are you going to do for tomorrow, or what is involved for next week. And being a beginner level, you need at least 2 hours to grasp everything what I'm showing it to you, and that gets you 2 points. So the end goal, everyone has to try to get 10 out of 10. So please be honest and try to get all of this, and post your achievements in Facebook group, so we learn from each other, and we'll also take these things forward. And there is combo internship coming up, as I don't want to cram a lot of information in one area. So I divide it into three sections or three modules. We are in the beginner, and if you want to learn the whole Cortex M4 series, please also purchase intermediate and advanced from us. So you will have the whole package of Cortex M4, and it is a good investment that you will. It is worth a lot. And also, this is on the process. There is more internship bundle combo coming up, and all this you will be getting through, and you will be the first person to know once they are become available, and you will be contacted to get that out to you. Once again, I thank you so much for your patience, for learning through today, and please go and have the deserved break that you are after. And it's been a pleasure to teach you today, to show you about the memory map and the bus interface. This is Arul Anbukarasu. I'm signing off on behalf of A2Digi. Huru from me, and see you at the next session. Until then, take care. Bye bye. Bye for now.